Hello guys, once again with determinant. So today we are going to discuss about the applications of determinants and matrices. And in the application of in this section, that means application of determinants and matrices, we will discuss the solution of linear equations. So we will discuss how to solve a system of linear equations using determinant and matrices. Right? In fact, we will use mainly the inverse of a matrix and the determinant of a matrix to find the solution of a system of linear equations. Right? Now, any system of linear equations may be consistent and inconsistent. Now, let's know what is consistent and inconsistent. So, system of linear equations. So, system of linear equations, it may be consistent or inconsistent. So consistent and inconsistent. So when a system of linear equations is called consistent when solution exists. When solution exists and solution does not exist. Right? So if a system of linear equations have a solution, then it is called consistent, and if doesn't have any solution, then it is called inconsistent. Okay? Now next, any system of linear equations can be expressed in the form of matrices, right? And from this matrix equation, we can find the solution. Let's see it. Suppose a system of linear equations is given by a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus C3z equals to D3. Then this system of linear equations can be expressed in matrix form. How can we write this? See here, these are the all coefficients of x, these are the all coefficients of y, and these are the all coefficients of z. So if we write a is equals to a1 b1 c1, a2 b2 c2, a3 b3 c3, right? And if you write x is equals to, if you write capital X is equals to, mind it, this one is capital X, and capital X equals to x, y, z, and b is equals to d1, d2, d3. Then the above system of linear equations can be expressed in matrix form. How? Ax is equals to b. How? If we multiply a with x, what we will get? This row will be multiplied by this column. So this one will be a1x plus b1y plus c1z equals to b. Equals to b. So here is the element d1. Exactly the first one. If we multiply second row with this one, you will get second one. If we multiply third row with this one, you will get third equation. So for that reason, we can express the system of linear equations in this form: ax equals to b. Now see here, see the magic. If we can find the inverse of a, the equation was ax is equals to b. Now if we multiply with inverse, a inverse in both sides, then what we will get implies that a inverse into a into x is equals to a inverse b, implies that inverse multiply, what is the result? This will be identity matrix, right? So if you multiply identity matrix with any matrix, the matrix will be exactly same. So this will be Ix is equals to A inverse B, implies that X is equals to A inverse B. So if you are able to find the inverse of A, then done, because just we will multiply A inverse and B and you will get the result. So this is the process. Now question A है, क्या A का इनवर्स हमेशा एग्जिस्ट करेगा? यहीं पर आ जाता है क्वेश्चन. अगर A का इनवर्स एग्जिस्ट करता है तब उसको हम सॉल्व कर सकते हैं, अगर नहीं है तो उसको हम नहीं कर सकते हैं. लेकिन इससे पहले वाला वीडियो में, in the previous video I have discussed how to find the inverse and using adjoint and determinant. So it was A inverse equals to adjoint of A divided by determinant of A. So whenever we are trying to find the inverse, we have to test whether the determinant value is 0 or non-zero. That means the given matrix is singular or non-singular. So if this one is non-zero, then only the inverse exists. So for that reason, the two cases arises. Number one, case 1 and case 2. For this equation, case 1. What is this? Case 1. Case 1. Determinant of A is not equals to 0. Whenever determinant of A is not equals to 0, that means the inverse of A exists. और इनवर्स जब भी एग्जिस्ट करता है सॉल्यूशन हमेशा एग्जिस्ट करेगा. और अगर किसी सिस्टम ऑफ लीनियर इक्वेशन का सॉल्यूशन एग्जिस्ट करता है तो उसको क्या बोलते हैं? कंसिस्टेंट. दैट मींस सॉल्यूशन एग्जिस्ट्स, दैट इज सिस्टम ऑफ लीनियर इक्वेशन इज consistent. Right? Now case 2. Case 2 में क्या हो सकता है? Case 2 determinant of A is equals to 0. So whenever the determinant of A is 0, then you can't say that the system is inconsistent, right? Because when you are getting this one, determinant of A is 0, then you have to check another condition. What is this? This one is, then you have to check adjoint of A into B. Adjoint of A into B. Right? So you have to check this one. If adjoint of A and B is, it may be not equals to 0. Here 0 means this 0 is not real 0. It is 0 matrix. Okay. And similarly, adjoint of A into B may be not equals to 0 matrix. May be equals to 0. Implies no solution. That means no solution. System is inconsistent. Right? जब भी तुमको डिटरमिनेंट 0 मिलता है उस वक्त तुमको और एक चीज कैलकुलेट करना है, एडजॉइंट ऑफ A into B. अगर A रिजल्ट फिर से नहीं 0 आया, 0 मैट्रिक्स, माइंड इट, दिस वन इज 0 मैट्रिक्स, नॉट 0. So if it is not 0 matrix, then there is no solution. The system is inconsistent. लेकिन अगर A रिजल्ट 0 हो गया, if adjoint of A into B is 0 matrix, then it may be consistent, may be inconsistent. Why? Because यहाँ पर दो केस आता है, एक या फिर इसका इनफाइनाइटली मेनी सॉल्यूशंस होता है या फिर नो सॉल्यूशंस होता है. सो इनफाइनाइटली मेनी सॉल्यूशंस. जब भी इनकॉन्सिस्टेंटली मेनी सॉल्यूशंस रहता है तब इसको बोलते हैं consistent, right? And it may be no solution, inconsistent, right? So whenever you are asked to find the solution of a system of linear equations, you have to form this one. Then you have to check whether the determinant value is 0 or non-zero. If it is non-zero, solution exists and the system is consistent. If the determinant value is 0, Then you have to calculate one more thing, adjoint of A into B. If adjoint of A into B is not equals to 0, that means you are confirmed that there is no solution. That means system is inconsistent. अगर adjoint of A और B मल्टीप्लाई करने के बाद इसको 0 मिल गया, तब दो केस हो सकता है, या तो इनफाइनेटली मेनी सॉल्यूशंस होता है. अगर इनफाइनेटली मेनी सॉल्यूशंस है तो उसको हम कंसिस्टेंट कहेंगे, और अगर नो सॉल्यूशन है तो उसको हम इनकंसिस्टेंट बोलेंगे. राइट. सो इफ यू आर आस्क्ड टू फाइंड वेदर the system of linear equations are consistent or not consistent, then just find the determinant of A. Also this one is called coefficient matrix. यहाँ पर जो A मैट्रिक्स है इसको coefficient matrix भी बोलता है. coefficient matrix. This matrix is also known as coefficient matrix. इसको variable matrix बोलते हैं और इसको constant matrix बोलते हैं. Okay. Now let's solve few questions and it will be more clear. Okay, so let's do that. Exercise 4.6. Exercise 4.6 and question number 1. What does it say? Examine the consistency of the system of equation in exercise 1 to 6. तुम्हारे NCERT बुक में जो exercise 4.6 है उसी में क्वेश्चन नंबर 1 से लेकर 6 तक कंसिस्टेंसी तुमको चेक करना पड़ता है. और यहाँ पर जो फर्स्ट क्वेश्चन है उसको हम सॉल्व करते हैं. द रिमेनिंग क्वेश्चंस यू कैन सॉल्व इट. ओके, सो द फर्स्ट वन इज x plus 2y is equals to 2 and next one is 2x plus 3y. 2x plus 3y is equals to 3. This one, right? So you can write this system of linear equations in matrix form. So what will be the A? The above answer. See here how to write the answer. The above system of linear equation can be written in matrix form Ax equals to B, and right here where A is equals to the coefficient matrix. What is the coefficient of x? 1. What is the coefficient of y here? 2. This one is 2. This one is 3. And x is equals to how much variable there? 2. X and y, this one, and b is equals to 2 and 3. Now to check the consistency you have to calculate the determinant of coefficient matrix, that means determinant of A. Now determinant of A is equals to determinant of 1 2 2 3, this one. So this equals to 3 minus 4 is equals to minus 1, not equals to 0. Since determinant is not equals to 0, that means therefore A inverse exists. Since A inverse is unique, जब हम लोग इनवर्स निकालते थे, क्या हम लोग एक मैट्रिक्स के लिए 2-3 इनवर्स निकाल सकते हैं क्या? नहीं. That means इनवर्स ऑफ एनी मैट्रिक्स इज यूनिक, और इसी यूनिकनेस के वजह से जब हम लोग इसका सॉल्यूशन मिलता है हम लोग को तो वो यूनिक ही होता है. दैट मीन्स एग्जिस्ट एंड द यूनिक सॉल्यूशन. Therefore the system of linear equations gives unique solution. Therefore the system of linear equation has unique solution, that is it is consistent. So this is the concrete answer. Okay, now try the remaining questions. You will be able to solve it, and I am doing one more question. I will not solve it fully, but I am just giving you hints. Question number 16. Question number 16. So this is a story sum and you have to solve this. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. And the cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. Find the cost of each item per kg by matrix method. So you have to find what is the cost of each kg onion, rice and wheat. Okay, now let onion X, rupees X per kg, right? Wait, rupees Y per kg and rice rupees Z per kg, right? Then from the first instruction, therefore according to question, 4 kg onion, so 4x plus 3 kg wheat, so 3y plus 2 kg rice, that means 2z is equals to 60. Next one is the cost of 2 kg onion, so 2x plus 4 kg wheat plus 6 kg rice, 6z equals to 90. This one. And next one is 6 2 3 is equals to 17. Now this is a system of linear equation and you have to solve this, right? So write the answer. The above system of linear equations can be written as Ax is equals to B, where A is equals to 4 3 2 2 4 6 6 2 3 and X is equals to X Y Z and B is equals to 60 90 70. Now calculate determinant of A is equals to 4 3 2 2 4 6 6 2 3. So this equals to how much? 4 into 12 minus 12 minus 3 into 36 plus 2 into this one. So this equals to 0. This one is 0, first one. Next one is minus 30. So minus 30 plus 90. This one is minus 22. So minus 44 is equals to 6 4 36, which is not equals to 0. Therefore the system of linear equations is consistent. That means this system of linear equations have unique solution. And how you will get? Now you have to find adjoint of A. Now calculate adjoint of A. Now calculate A inverse equals to adjoint of A by determinant A. First calculate this one, then you will get A inverse and just write X equals to A inverse B. Already you know what is B. now calculate A inverse and multiply A inverse with B, get the answer. Okay, thank you guys, that's all today. You should try exercise 4.6 by yourself, and if you have any problem then I will discuss that on the next video. चलो मिलते हैं नया चैप्टर के साथ.